Okay. Hi, everyone. I'd like to thank you for joining us for today's webinar on optimizing geothermal installations in existing municipal facilities. My name is Catherine Wilson. I am manager of the Mayor's Megawatt Challenge, a program that's been working with municipalities since 2003 to reduce energy use and emissions in their own facilities. I would like to thank our program sponsors, Enbridge Gas and Simcoe Refrigeration, and today's webinar sponsor, Perkins & Will. We're continuing with our theme of practical pathways to net zero carbon buildings, and today we'll be exploring geothermal in existing facilities, including factors for successful installations, as well as common issues encountered with existing systems and how they can be addressed. Procurement will also be discussed, including what municipalities should be asking for to ensure successful installations. The aim here is to provide practical assistance to municipalities that have both existing geothermal systems that may or may not be working and what they'd look for in installing a system in an existing building. So here is today's agenda. After the welcome and introductions, we will set the stage and then move to practical design and installation considerations. We'll then be moving on to the City of Toronto's experience. They will share their experience with geothermal. Moving on to procurement and financing of geothermal systems. We'll then have a panel discussion on successful operation of geothermal systems, followed by a Q&A and closing remarks. Just a few instructions for today. So concerning the logistics, if you have technical questions about the Zoom platform, if you could enter those into the chat box. If you have questions for individual speakers related to content, please enter them into the Q&A box. So we will address all of the questions at the end of the webinar, but please enter your questions as we go, and we'll also circulate a Q&A document after the webinar. So I'd like to take this opportunity again to thank Perkins & Will for their generous sponsorship of today's webinar. And we're pleased to welcome Zaina Alali, the Senior Sustainability Advisor from Perkins & Will, who will speak to the role of designers in system integration and take part in the panelist discussion. So our other panelists for today, we're thrilled to welcome Diane Skorick, Jeff Hunter, and Paul Frith to the panel. Diane is the Senior Project Manager at the City of Toronto. Jeff Hunter is the Vice President of the Ontario Geothermal Association. And Paul Frith has been working in the industry for quite a few years and is on the Advocacy Committee of the Ontario Geothermal Association. Okay, so just to set a bit of context, this diagram will look familiar to many of you. So this is what we call the roadmap or pathway, which follows a systematic process to identify 4 areas of the integrated solution, starting with energy efficiency to really improve operations and equipment efficiency in the buildings, and then heat recovery to put as much of the waste heat as possible back into the building. And then integrating renewables, and geothermal would fit in here, to cover the remaining demand, and leaving purchase credits and other offsets as the last resort. So one of the ways geothermal really exemplifies this approach in the way it demands changing traditional thinking. So as our panelists will be discussing in more detail, it really leads to thinking differently about the design of building systems, as well as how we procure and cost the systems. So there's really 3 pillars of geothermal that are critical to the success. And these are design, drilling, and integration. So today's panelists will speak to what needs to be considered under each of these pillars. And I will now turn it over to Zaina Alali from Perkins & Will to speak about some of the design considerations.
Thanks, Catherine. So when I'm talking about design, it's not necessarily the design of the geothermal system. There are other experts on this panel that can speak to that. What I'm speaking about is sort of integrating the geothermal evaluation process into the overall project design. And what we learned is you have to start it very early in the project. We're sort of at a point where every single project that we are working on needs to be evaluated for net zero carbon, the achievability of net zero carbon, and at least building a path towards zero carbon if you can't get it off from day one on a new project, for example. But essentially, at some point between now and 2050, you're going to have to achieve zero carbon, and doing it at a time when you are renewing your mechanical systems or you are starting a new project is a very good and the most cost-effective time to integrate geothermal. And so we want to, I guess, basically along the path, everybody on the team has to acknowledge that change is necessary. The client team, the design team, we both need to, as Catherine mentioned earlier, acknowledge that if we do things the same way, we get the same results. So it really needs to have, we need to have a mind shift in terms of thinking. Not everybody's familiar with geothermal process and operating geothermal systems, but that's a necessary lesson that we all need to learn to be able to do things differently. We have done several energy analysis and carbon analysis on our projects, and what we've realized is you can achieve significant energy and carbon savings by using geothermal systems, upwards of 30%. So that's not a number or a percentage that you can ignore. That's something that you probably really need to take seriously. So you need to start the evaluation early. We're bringing the geothermal experts right to the table, right from the project onset to do it. And you need to think about the pros and cons of the process. A lot of people are focused on the financial exercise, how much is it going to cost, and what's it like to maintain, but you also need to think about the other aspects. In terms of freeing up real estate, because if you reduce the mechanical systems on your rooftop, now you've got real estate to do other things and have an accessible roof, or you can allow PV integration into your project and produce renewable energy. Again, back to the net zero carbon path. And you know, there's a misconception that geothermal always needs to be next to the building and that you have to have a lot of field within your site, but the truth is you should also be evaluating it under your building. And most people actually tell you that it's probably the best spot because it opens up the field next to the building to be used for other things in the future. And you need the right expertise. The last point, you need to have the right expertise at the table right from the onset. Lots of people, lots of consultants feel that they're able to do geothermal design, but the truth is you need somebody who has ample experience doing geothermal to ensure that you have the right design. It's not over or under designed. And they need to be involved in the costing exercise. And you also need to have an energy analysis on your project done fairly early so that you can evaluate the extent of energy savings, create return on your investment calculations, and figure out and basically have all the information at your fingertips to be able to figure out whether you want to integrate geothermal on your project.
Well, that's great. Thanks very much, Zaina. You've really given municipalities some things to think about, and particularly bringing it into the equation early instead of after the fact, I think is really, really key. And involving those experts, people who really, really know what they're doing in this space. So I think those are really, really important points. So thanks very much for that. And if anyone has any questions for Zaina, please type them into the question and answer box, and we'll be sure to get those addressed in the Q&A session. Fantastic. Okay, I will now turn it over to Paul Frith, who will speak to drilling considerations when installing geothermal in existing facilities. Take it away.
Thanks very much, Catherine. Because this is a discussion around existing systems, I'm probably going to touch more on the drilling and the costing side of it on procurement. So I'm just going to talk a little bit now about the importance of drilling. And I guess the most important piece you need to understand when you're looking at geothermal from a costing perspective, drilling is clearly the most expensive thing that you're looking at. So these are a couple of the things that you need to remember or think about. One is geology. And one thing you'll find is there's certain areas of the province where drilling can sometimes be upwards of 40% less expensive than other parts of the province. And that's all based, like I said, on geology, overburden, those types of things. So one of the first things that we always recommend is that you do a test borehole just to see what the thermal conductivity is like in the area. Just that's around the viability, and to see what kind of energy you're going to get out of that field. That doesn't cost you a lot of money, and it saves you a lot of problems long term. There are regulatory things you need to be aware of, and there are certain areas of the province where there are flowing aquifers, and if those are there, you're only able to drill to certain depths, and if you don't know that, you could run into some problems. So you always want to look into that. And the configuration is very important, and this goes back to what Zaina was talking about. You want to make sure with your design that you have somebody that really knows what they're doing, because with the first 2 points I made, they have to be aware of that information, because that could impact the depths that you're going to, which in turn would impact the costs. So you really have to have somebody that really knows what they're doing. The one thing I say when you're talking about geothermal, it is a specialized skill and technology. So you shouldn't be treating this like you're buying ballpoint pens or something. This is something where it's very specialized. And I will allude to this in procurement a little bit later, the importance of that. And to go back to Zaina's point, drilling from surface or underbuilding drilling, there's a lot of benefits to that, and whether that be to free up real estate across the property or from a schedule perspective. If you're drilling from surface and under the building, generally speaking, the geothermal driller is the first one on site, so they can get everything done, have your bore field in place, and that's before any other trades come on. And I saw a Q&A came here, so I just want to check to make sure. Oh, this is for me. So geopipes are under the building. If any future repair works, how will it affect the building? What is the likelihood of such things? Generally speaking, if you're going to have problems with the pipes under the building, you'll see that fairly early on in the construction project. When you drill from surface early, the field is there. So if there's going to potentially be any damage, say an excavator or something hitting a loop, you would know about that very early on. So the likelihood of there being problems long-term post-construction are slim to nil. In the event that you would have to do repairs, there are ways to diagnose those types of problems. There's just different tests that can be done. One thing that we generally speaking recommend is you do add a little bit of extra capacity to the building. So in the event, the unlikely event that something goes wrong with a loop, you could always isolate that loop and still have enough capacity from your system to be able to fully manage the building's loads. So it's very, very rare. I don't think, and I've been in the industry, or I was in the industry for 7 years. Not once did I see that happen. It's just not a common thing that happens, but if it does happen, there are tests that can be done and it can be addressed in answer to Raji's question. So that is all for me. I'll be talking again once we get into procurement. So thank you very much, everybody.
Thanks, Paul. That was great. Thanks for addressing that question there. Okay, if anyone has any additional questions on drilling, we can get back to those in the Q&A session. So I'd now like to turn it over to Jeff Hunter, who will speak to integration considerations, the issue of seasonal imbalance, and the impacts on mechanical systems.
Great, thank you. First of all, thanks for inviting me to be part of the conversation. I'm excited to be here. And I know we're focusing a lot on existing facilities and existing systems, but I want to take perhaps like a zoom out and more generic conversation up front, and that I think will lay the groundwork for a good conversation in existing facilities. So to start, I think everyone's probably familiar with the image on the screen. It's a gas meter, or it could also be described as, or as I would describe it, as a infinite or perpetual energy machine. And what I mean by that is, as long as the utility bill is paid, there will be energy or BTUs that will show up at the other side of that meter. And in our process of mechanical design, we really don't, in conventional systems using gas, we really don't think much beyond that. We don't think about the other side of the meter. And that's, in fact, what we pay the utility to think about. The utility works on sourcing that gas, operation and maintenance of the hundreds and thousands of kilometers of gas piping to bring a cubic meter of gas to the building. So I think I'm just trying to lay out conventional systems and how it works in conventional, and then we'll have a conversation on the geothermal side. So conventionally, when we're looking at mechanical equipment in the building, we're typically sizing to peak loads. We want to make sure that our equipment operates in the worst case scenario. So peak load in the wintertime, somewhere around that design day, it occurs, maybe 2.5% of the year. We want to make sure that the occupants of the building are comfortable on that day. And the same thing in the cooling season. We're designing the peak there as well. We want to make sure that occupants are comfortable in the peak cooling season. Now, in cooling, in a conventional system, we're rejecting all of our cooling energy to atmosphere, either through cooling towers or fluid coolers, some sort of evaporative cooling device, or a direct exchange device like a typical air conditioner in your house is a condenser coil. So all of that cooling energy is being rejected out to the atmosphere. In the heating side of things, on the other side of our gas meter, we're essentially bringing fire into our building and combusting that gas to produce the byproduct of heat as one of the byproducts. And that's what we're harnessing for heating, space conditioning, and domestic hot water heating. The other byproducts are, of course, why we're here, because they're not so good. And those byproducts, too, are rejected to atmosphere. So next slide, please. So then we look conversely at the geothermal system, and this is a finite energy source. And I want to be careful in how I describe this. I mean finite in the sense that you see the red dots there, I've underlined the loop field in this particular building. This is a three-dimensional block of earth that has become our energy source for this building. Now, if all things are done properly and design is done properly and the building is operated properly, that is essentially an infinite source of energy. That building will operate infinitely off of that thermal energy source there. But it's finite in that it's truly defined in that sense. Because if it isn't designed properly and we haven't assessed it properly, that block of earth, that block of earth could freeze. If we take too much energy out of it, that block of earth could overheat if we try to reject too much energy to it, causing the system not to fail. So it's a bit of a balance. Actually, it's incredibly a balanced conversation. So the heating and cooling loads, which the major difference here between a conventional system and geo is that our heating and cooling loads are now connected. The common source being the loop. The loop acts as our thermal source for energy in the wintertime, and it acts as our thermal sink in the summertime. So common source. It's like a thermal battery where you're charging it up in the summertime, and then the wintertime we're discharging that energy. So that annual balance is absolutely important. It's also like a bank account. If I keep going to the ATM, extracting money from my bank account without putting money in, well, eventually I'll go broke. So it's similar to this thermal energy situation with ground loops. So it's critical for long-term performance. And to throw a bit of a monkey wrench into this, with high performance buildings and with larger buildings, and I'm thinking of office buildings or other spaces, oftentimes buildings today are cooling dominant, even in a northern climate like Canada. I heard a number recently on a course that N-Wave Energy operates a cooling water loop to a lot of buildings in downtown Toronto. And I heard on design day in winter that they're still at somewhere around 20% capacity on their cooling loop. So even in the coldest day in the wintertime, their cooling loop is still using about 20%. So that throws a bit of a monkey wrench into the balance equation as to how do we deal with that. And certainly in high performance buildings, once we've addressed the envelope and we've tightened up that envelope so much, now oftentimes we're seeing that those buildings are cooling dominant as well. So that requires accurate and detailed energy modeling. That was talked about before from the building side of things, but also on the energy source side. So with the conventional system, the gas utility is doing all that work to get the pipeline in place and get you the natural gas. On the geothermal side, we need to model that energy source based on the loads that are connected to it. And that's more than just understanding peak loads. That's understanding monthly loads. That's understanding annual loads, and that's even going to 10, 20, 30 plus years beyond to see the long-term performance of that loop, because minor changes in operation of the system, how much energy is being taken in versus how much is going out, those compound over long term and can have a major impact on the performance of the system in the long term. So we need to be modeling the thermal performance of the loop, but also very accurately modeling the building performance. And that offers us in the design phase the opportunity to iterate and choose our mechanical systems wisely and our building systems to understand the impact of, say, a reflective roof or a green roof, or changing solar heat gain coefficient values of the glazing, or all that stuff will impact the energy in and energy out inevitably on the ground loop. And also, my final point, buildings are dynamic on this slide. Buildings are dynamic. Daily operations, again, compound in the long term to impact the performance of that loop. So it's important that if, let's say we have an office building, office building starts up at 8 a.m., people start coming in, lights come on, computers come on, ventilation systems turn on. We need to be accurately following those schedules and have those schedules and having the building perform as it should to ensure long-term performance of that ground loop. Okay, next slide, please. So with that respect and iterating and choosing mechanical systems, my first point here is on ventilation, and I'll tie that to high performance buildings, because you find as the envelope gets tightened up so much, the ventilation load in the building now becomes a major component, or energy component, right? We want to bring in fresh air from -20 outdoor air, or we want to exhaust air and bring in fresh air from +30 degrees Celsius. So making a decision on ventilation systems now is more than just throwing a gas makeup air unit in there and expecting that to be the trick. Now we need to talk about heat recovery and even total energy recovery systems, because the energy that we put into, first of all, heating the space, we want to recover as much as that as possible, and we don't want to reject that to atmosphere, but also the energy on the cooling side, both for humidification as well. So if we've dehumidified the air through cooling energy, we want to recapture that, and we don't want to be introducing more humidity than we need to. So the difference between a standard performance heat recovery ventilator and an energy recovery ventilator that is passive house rated, that can give you an effectiveness of 85% or greater, the differences in effectiveness there will have a long-term impact on the performance of the ground loop. Same thing with heat pumps. So COP does matter. I know it's the difference between looking at a heat pump with a COP of 3.5 or 4 as compared to a gas boiler with a 95% efficiency. I mean, we're leaps and bounds greater. So you kind of think, well, how much of a difference is it? Well, now when we start comparing heat pump to heat pump, small variations in COP again compound in the long term. So selecting the appropriate equipment for the best performance is a critical factor. Now in retrofit situations, and I've gone through this myself with retrofits of schools, existing schools may be on conventional systems, boiler cooling tower with existing heat pumps. Sometimes it's tough to take a heat pump from the 70s or from the 80s and that was on R22 refrigerant and upgrade it to a new heat pump that's on a newer refrigerant. They may not be the same efficiency comparative, and they might be larger units, so you're kind of bound in those constraints, but COP does matter. Now, in larger buildings with central plants, there's an image here on the top left there. That's a modular heat recovery chiller. Central plants can be retrofitted to heat pumps these days. Heat pump technology does allow for higher temperature applications. Let's say existing buildings with higher temperature baseboard radiator distributed throughout the building. Yeah, we can meet those higher temperatures, but again, we need to be conscious of the difference in temperature, the lift that the heat pump needs to take the source energy to the heating temperature for those rads. So we need to be conscious of the lift, but it certainly can be done. It just impacts the efficiencies of that equipment. And so thinking differently about geothermal systems means, okay, well, what are some other heat sources and sinks that we can combine here to help balance our ground loop system? And so certainly with cooling dominant applications, we want to try and look at heat sinks where we can reject to avoid rejecting too much heat to the loop. So domestic hot water comes up as an immediate. If there's a building with a fairly large domestic hot water load, we can use that to dump into. Snowmelt is very beneficial for buildings. You can dump excess heat and keep walkways clear and all of that. Ice rinks are a fabulous opportunity because certainly in complexes that have ice rinks and say swimming pools put together, we're trying to freeze the surface of the ice. So we're taking as much energy as we can out of that, and we want to dump that somewhere else. Well, we can dump it in the stands, we can dump it in to heat a swimming pool in an attached complex. Fluid coolers, it ties into my conversation here about hybrid systems. Now we were in design and iterating, we're iterating to optimize the geothermal loop for balance, but that also impacts the economics of the project. And sometimes available land area or cost factors won't let you do 100% geo, let's say. If you incorporate hybrid systems like a boiler and a fluid cooler in these types of systems, you can bring those economics and even the feasibility into a range that's acceptable for the owner of the building. But caution here, because controls and commissioning in any case is absolutely important. But certainly when you're introducing conventional system hybrid into a geothermal system, we don't want to be overheating the loop. So you could have a boiler that's heating up a loop without knowing about it, or you could have a fluid cooler extracting too much energy from a loop and you want to keep that. So control systems and commissioning becomes very, very important in those situations. Okay, that's all.
Oh, that was fantastic, Jeff. Thank you. It was really good to see the perspective and really the impacts on the mechanical systems, really important things for people to be considering here. So if anyone has any questions for Jeff, please feel free to enter them into the Q&A. And I will now turn it over to Diane, who will provide the municipal experience, speaking to geothermal at the City of Toronto.
Hi, thank you, Catherine. Thank you and welcome to, I guess I'll start first with just looking at next slide. Just a reason why we are really talking about the geothermal, as mentioned a couple of times already, it's a path to net zero. This is just our very early graph on how we need to drop our in City of Toronto from greenhouse gas emissions down to almost to zero by 2050. And just to point out that we expect that low carbon buildings would be making almost a half of that reduction, will be responsible for that. And I believe wholehearted geo would make a big part of that. So the next slide. I was talking about previously just on the community-wide emissions, but City of Toronto as a municipality, and we obviously have to get our own house in the order, and we have to get our buildings and to net zero as well. So the target that we have is that all new city buildings will be 100% near net zero or zero carbon, and the all new existing buildings will be retrofitted by 2040. That's on our books. That's what we are aiming for. On the next slide, just on the going a little bit back in the history on what we have right now, where we are with the geo experience is we have about 15 buildings with geo. Actually, if we add the Toronto community housing buildings, there is over 20 buildings with the geo systems. The oldest is pretty much over 30 years old now. And that number is fairly low compared to the number of buildings that we have as a municipality in Toronto. But it also covers the variety of buildings. So you have community centers, police stations, police training stations, childcare centers, even the retrofit on the heritage office building. So even though their numbers are not large, they cover the number of other buildings. On the future outlook, I think the key, as I mentioned a number of times, is that heat pumps will be essential to achieving net zero buildings and including retrofitting existing buildings. And I would say, yeah, sure, we could aim to achieve them with electric boilers or maybe baseboard heating, just electrifying the buildings, but that well, first of all, grid would not be able to take it, and our taxpayers would cry for the money. So really, the heat pumps are the way to go as the most efficient type of the system that we have right now. So all our new buildings are currently designed by using heat pump system, and I'm talking about both ground source and air source heat pumps or a combination. We have at least 10 to be planned to be built in over the next 3-4 years. One is under construction. As well, we are starting with those deep retrofits, 2 pilot deep retrofits that will include ground source heat pumps. Will be completed this year. Actually, the one starts drilling next Monday. So we are just in the beginning of the construction period. It's important just to, that illustrates that over the next 3-4 years, we will probably reach those 15 buildings that it took us 30 years to get to. So it is increasing. The number and size of the systems are increasing very fast. So on the next slide, if we go, I divided a little bit on talking about feasibility design and then later on construction operation. The key again in the past is that majority of geo have never been through the initial discussion. We discussed it a number of times. What we tend to get from consultants at the time was pretty, quick rules of thumb and back of envelope type of assessments. Sometimes we'll come back with 200-year paybacks for the geothermal projects. In cooperation with TRCA, we have developed the feasibility, geothermal feasibility terms of reference, which requires energy modeling, like Paul mentioned earlier. That's critical, geology, investigations. We can share the link to it. It's on the TRCA website. It's available to anybody to use them. If you want to incorporate that as part of your selection for the RFPs for the selection for the consultants. Obviously, the key, as I mentioned before, the geothermal is an integral part of the HVAC system. Obviously, it's both valid for existing buildings and the new buildings. And I would reiterate again that it's energy storage system. It's it's like a bank account. You have to keep. You cannot just withdraw from it. You have to put money back in order to survive. In order to allow you to continue withdrawing. So it has to be balanced over time. One thing is again going off what Paul was mentioning before. Conventional system, we do size the systems for peak loads. For geo, I would strongly recommend sizing for average annual load and using a backup boiler if needed to heat building during the 5-6 days in a year that is actually needed. That will just limit the oversizing of the geo system. And one thing as well that we have to pay attention in because of the climate change that we are going through, next 20-30 years of the climate change is pretty much baked in. Sorry, for the pun. So I would say that system sizing really needs to take into account that. We have to and more and more buildings, and as they high performance buildings, but more and more buildings will be cooling dominant versus the heating dominant as well. And that comes to the balancing of loads, which Paul already explained to. So we can go to the next slide. On construction and operation, and I really want to. It's really important to say that main challenges are not necessarily related to geo. Sure, you can have some specific geo problems on the projects, but what I've experienced is that most of the problems that we have with geo are the problems that we have on other projects, and starting with quality of installation work. Drilling can be typically with. I have not had much drilling issues with the drilling. I had many more issues with the inside work, with the plumbing, with the plumbers not reading drawings properly and reconnecting on the wrong side. So we had to catch that and redo the work. We had issues with if you have steel pipes inside that and you have glycol, you need to have rust inhibitor, for example. And yeah, so in one particular case, they didn't put rust inhibitor. So our heat pumps blew up after 2 years because of all the gunk that was in pipes. So those are, has nothing to do with geo. It has all to do with the quality control and quality assurance of the project. So that leads into the thorough testing and commissioning. It's absolutely crucial for high performance building and where we're going. We will not be able to have net zero buildings that functioning as a net zero buildings without proper commissioning and without proper monitoring verification. So the clear monitoring plan is essential. Again, that's not related directly to geo. Things like simple things like BAS access, remote access, the BAS is able to trend and store information. So if you have to do some troubleshooting, that you are actually able to figure out why, what happened. If there is no data, we cannot help. It's very tough to help. You have to go and do forensic analysis, and that obviously takes time and cost while the building is probably lacking the heat. It's not being cooled properly. Training operators, that is part of the design, as part of the commissioning and monitoring plan. We have to enable operators to know, for them to know. So first of all, is educate and train them, but also have a kind of short cheat sheets for them, so they're able to know if heat pump starts short cycle all of a sudden, what they can do. If the temperature in the loop is going higher than what we told them that it should be at this time of the year, are there simple actions that they can do instead of letting it go until it's too late? So usually, this whole thing is about preventing the problem. So that's what we should aim for. I mentioned here short cycling. It really starts in design stage, obviously. You have to either put a buffer tanks or but it's from the operator point of view, they need to know what is a short cycling and what they can do to stop it. Either if not, then heat pumps after time, like any other mechanical system, can run the problems and burn out. And it comes down to typical basics and maintenance as well. It could be as simple as changing filters. That makes a big difference. So next slide. I would say though, these previous 2 slides, you can say that those are related to all the buildings, and new and existing projects. There are specific considerations, I guess, for the retrofit buildings and existing buildings if you want to add geosystems. It's crucial to address the overall health of the existing HVAC system. The moment we start adding the geo loop, and we're going from potentially, if it's a conventional system there, from the high heat to low heat systems, the moment we touch it, we own it. So anything that ever happens in the HVAC system, even in distribution of the systems we never touched, it tends to be our fault for the geo project. So it really is key that we assess and address all the whole HVAC system, and it's best if it's done as deep retrofit, very integrated approach with multiple efficiency measures. We're addressing the ventilation, addressing the building controls, if possible, addressing the envelope as well, because geo is very efficient, but if you have a leaky building, what we tend to do is just waste heat more efficiently. So if you can, if any case, I know obviously for retrofits, that's sometimes it's tough because of where the life cycle is of the building, but if possible, address envelope and either at least plug it so it's it's not leaking as much. Obviously, the best time to do is when major HVAC equipment is due for replacement. So over the next 20 years, you pretty much will have major equipment for replacement. so that's the best to plan it and integrate with existing system is a key. Spending time and money to reduce and properly balance the building loads. The new energy loads will allow us to reduce the amount of the size of the drilling, the borehole field. Because what we are really looking is the sweet spot between the site geology, building condition, and mechanical system. When you're talking about the existing buildings, when you're doing retrofits, it's very hard to drill under the building. So you're kind of limited to whatever area you have around the building itself. So that may be a big limiting factor. In one of the two retrofits, we are actually had to go with a hybrid system where we are combining air source heat pumps with ground source heat pump and conventional boiler as a backup as well. So it's kind of all in one, just because it's very extremely tight site, so you cannot drill as much. And I always like to say that the retrofits tend to be like peeling with the onion, so expect some tears there and surprises. So as large contingency as you can get, it's a great. And not to forget, because on existing buildings, we need to establish what the baseline is before retrofit. That will help with monitoring, energy reporting, so that we can provide to public as well, to the mayor and the councillors and our senior management business case and proof that this project, these deep retrofits work well. And next slide. I think we are in Q&A.
Yes, we are. Thank you so much, Dan, sorry. Terrible pronunciation. I'm so sorry.
No problem.
But yes, the municipal perspective is so important to the other municipalities. So I think they really learned a lot from what you had to share. And we do have some questions for you.
We have a ton of questions, Catherine. I've been answering them as best as I can along the way. So to all of the folks that are putting questions out there, thank you very much. Some of them are pretty complex, so it's a little bit difficult just to put a straight up answer in there. I'll just answer a couple of them really quickly, if that's okay. One, someone was asking about regulatory impacts in relation to aquifers, and I know that was directed at Dan. The regulatory question around aquifers is going to be very specific to certain municipalities. Generally speaking, you don't run into those types of issues unless there is an aquifer specifically that's supplying the drinking water. So we've seen places like Guelph, for example, where they've had concerns around this. But from a permitting perspective, and actually just to give a more broad statement, there are thousands and thousands of geothermal installs across Canada. The technology has been around for a very long time. So when you talk about impacts on aquifers, it can still be done even if it does feed the drinking water. There's just a process that has to be followed to make sure that you don't have a negative impact on that drinking water. And that's all about having top quality drillers knowing exactly what they're doing and having a clear plan to be able to work with that. Not only the drillers, but also the consultants. There was also a question on there around economics and paybacks of geothermal. I'm going to give a very broad answer to this, because when you're talking about economics around geothermal, every building is different. There is not a specific answer to that question, unfortunately. At a very high level, when you're talking about buildings, the average is somewhere between 7 and 9 years, but depending on when you turn your cooling on and off, if you have a 2-pipe fan coil type system, those numbers can vary dramatically. Versus a house, in comparison to natural gas, you could be 20 plus years payback. So you've got two different business cases. You've got to look at what are you comparing it against. You've sometimes got to factor in internal infrastructure costs associated with that. So unfortunately, it's not a black and white answer. So to the person that asked that question, I apologize if I'm generalizing a lot, but it's almost impossible to say what is the payback. the benefits are pretty obvious. You're getting rid of natural gas, you're getting rid of carbon, your operational costs are going to go down, you're eliminating coolers, you're eliminating chillers, you're creating roof space on buildings, and the list goes on and on and on. But to get into specifics around economics, that's very difficult because buildings are so different. So that's just a couple of them.
Great, thanks, Paul. There's another question that I believe you tried to answer, but maybe Dan has something to add there. So Dan, have you had any regulatory issues with approval of vertical systems? You're in Toronto.
Oh, I'm not. No, not that I'm aware of. We have never had any problems with our systems. The driller, the building, on the vertical systems, no. The only question is it was all addressed kind of is I prefer if they're using for drinking, you may want to talk about that. Closed vertical systems are generally not interactive with the environment except for the heat and being transferred there. If you're talking about the open loop system, then obviously that's a different story. Then you have to go through a big hoops to jump through to get the permits to take the water and then put it back in. But otherwise, I would say typical standard closed loop vertical system, no issues.
Great.
We just got another question on there around central systems and shared buildings, and that is becoming more and more commonplace, or at least it's being looked at a lot more. There aren't a ton of systems in Ontario and Canada that have shared buildings. There's a couple of west examples would be, I believe Drake Landing has a number of shared buildings. I believe Lulu Island has a number of shared buildings in Ontario. There are not a lot, but I can speak firsthand to tell you that there are a lot of projects in play right now that are looking at that. There are tons of benefits aside from the carbon in going down that path. Upfront capital cost savings, and I'll touch on that a little bit more once we get into kind of that financial and utility discussion. But to answer, and I don't know who asked that question, but it's been done a lot. You don't have a lot to worry about. It's not like it's something that's new.
Okay. Does anyone else have anything to add there? Maybe know of future or planned specific projects?
Yeah, I know inside Toronto. University of Toronto is in construction on their district geosystem right now. So, and for us, redevelopment of the Etobicoke Civic Center, that all those buildings there that will be built are being planned with the geothermal district system. That's a new development. It's while obviously U of T is tying their existing campus to the district geo. So we have both examples.
Great. Thanks. And I just see here in the chat that Whitby has just completed a feasibility study for district energy geo system as well. They'd be happy to share some, or pre-feasibility. So that would be fantastic. Thanks to Jake for that.
By the way, there's a question here from Jeff. We're asking if certain regions of Ontario, are they better than others geologically for geothermal? I think the simple answer is yes, especially from a cost perspective. And that's where working with hydrogeologists and people that really know the industry will be able to give you words of wisdom on that. There are certain areas where you could be dealing with aquifers. There are certain areas where you're dealing with really high overburden. There's a lot of different ground conditions that you can be dealing with. There was a project I was involved in, I guess it was last year, where once we did a test hole, we found that there were like old oil tanks underneath. So that's where geology is really important. But in general terms, Southern Ontario is pretty good with a few areas that are not spectacular. Southwestern Ontario has some challenges, but it can be done. Ottawa has some challenges, but it can be done. It can always be done. Just make sure that you're working with the right people that understand the geology really, really well. That's the most important thing we can say, is make sure you're working with people that know what they're doing.
Fantastic.
Sorry, Paul, are there other areas in Canada too? Because we're not just Ontario on the line here.
Oh, sorry, I thought it was all Ontario. I apologize for that. So once you get into the Canadian Shield, you're dealing with different drilling techniques. So once you get into granite, it's a completely different process, but it can be done. And when we're talking about geothermal as a whole, like I mentioned earlier, there are thousands upon thousands of installations that have happened across this country, and it can always be done. Are you going to run into areas where it can't? Sure. You know, if you're dealing with significant gas, for example, it may not be shale gas, I should say, it may not be recommended to do it there, but generally speaking, it can be figured out unless you're dealing with really a severe situation. So generally speaking, it can be done in most places.
Great. I'm just seeing in the chat, there's some interest in other municipalities seeing the pre-feasibility on geo and district energy, and we will send that out. Whitby has offered to share that with the group, so we will send that out afterwards, as well as the TRCA document, which has also been made public, so we can share that one as well. Okay, let's see. Is there anything that we've missed here specifically for Diane? Anybody?
There's one there from,
yeah,
Sorry.
there's another question that just came up.
yeah, I'll take the one from Stephen there that just came up, if there's a moment to do that, just about replacing HVAC systems and any concerns with, so it's like water source heat pumps, so a conventional boiler cooling tower loop, I think is what he's referring to. And so the main concern I've seen in those situations is just heat pumps have changed from, 20 years ago. We've changed refrigerants. And so the physical size of the heat pumps, if you're talking about a distributed heat pump system, the physical size of the heat pumps have actually changed. And so sometimes the challenge is fitting in the newer heat pumps that are working off of R410A refrigerant, which usually have larger heat exchangers, fitting them in the same footprint as the older water source heat pumps. So I think that would probably be the main challenge. And then that I think was already mentioned prior, but just ensuring that obviously when you're integrating with existing distribution systems designed 20, 30 years ago, temperature ranges are usually, we want to lower the lift from the source to the sink, right? The lower the lift is, the more efficient the whole system will be. So looking at distribution systems and any way to improve those distribution systems and lowering the temperature will be advantageous.
Perfect.
I'm answering a few questions as we go along. I hope you don't mind, Catherine.
Okay, no, I can just highlight some of those in case people aren't following that along. We had a question about a reasonable cost for borehole test for a geosite. Depends on geology, but somewhere between 30 and 40,000 would be a safe range.
Yeah, that's the safe range.
Yep, okay. And also, do we have a list of experts you would consider qualified for completing a geological study?
Yeah, and I had said we can put that through the OGA. I don't think it's we shouldn't be publicly kind of saying here's who's good and not good. So what we can do is we can refer them to the OGA. And a lot of people on here I already know, so I've had this discussion with people, but that's probably the best course of action as far as vendor recommendations.
Sounds good. Okay. I think moving on, again, thank you so much, Dan, for taking the time to share your story with us. Again, municipalities really appreciate hearing from their counterparts and others, so it was really, really helpful.
No problem.
Okay, and moving on to procurement and financing.
Okay, so I guess that means it's my turn, right?
That means it's your turn.
Okay. So guys, there's been a lot of questions throughout while this has been going on around procurement and critical areas and that type of stuff. The first thing I'm going to start with is to always remember that a geothermal is specialized. So you can't treat this like a commodity item, put out an RFQ, go for the lowest bid and assume everything's going to go fine. It's just because it's specialized, you got to have people that really know what they're doing. Even when you're selecting your mechanical engineers, they could be great at internal systems, but if they're not, if they don't have in-house geothermal people, then it's recommended that they engage with a boutique mechanical firm that specializes in geothermal. We always recommend having that piece that really understands it. But to take it back even a further step, if you are a municipality that has never done geothermal, I recommend either A, getting a third-party consultant involved, spend an extra couple of $1,000 to have somebody on board that knows the process inside and out and can walk you through it, or at the very least, get a cost consultant that understands geothermal that can walk through all of the different pieces. From a procurement standpoint, I don't want to go into too much of a rabbit hole here because there's a lot of different pieces I can talk about. But as we mentioned earlier, there's 3 key components. You got to make sure you have a good design. So you want to work with somebody that has a really good track record from designing geothermal systems. And there's a handful of people in the country that are really good at that. You want to work with a driller that's really well qualified. And there's ways to look at that aside from the traditional references that people give you. There are, like, for example, the Ministry of Environment, Conservation and Parks, and I hope I have it correct. I might have the ministry name wrong, but they actually have a way where you can go in and look at the record of the driller and you can see if they've had issues along the way. So that's something you can do to validate the drillers, but also look at the organizations. How long have they been around? Are there a lot of repeat customers? And one thing I've always said when I ask somebody for references, I say, don't not only give me a reference, but give me a bad reference. The person that isn't working with you, I want to know why they're not working with you. So you can ask everybody for that, and everybody has that. They won't like it, but it's going to protect you. There are a few documents out there from a procurement standpoint that I personally have been involved in that goes really deep. There was one that we did with Infrastructure Ontario a few years ago where we made sure to cover everything off, where we had third parties on site checking depths of holes or doing bag counts on grout or making sure grouting is done properly. Like I said, I don't want to go into a rabbit hole here, but there's a lot of different elements that you do need to look at when it comes to the drilling process and getting the design tied into the drilling and the drilling tied into the integration. And you want to make sure all 3 of those pieces are working seamlessly. So I think that's all I'm going to do, just in a general terms. From a procurement standpoint, it's just don't treat it like it's a pen or it's a commodity. There's one municipality I'm talking to right now where they're making exceptions for geothermal and they're not treating it based on lowest price. They are looking at this as a specialized trade, and in turn it's getting special treatment. And there's other variables that are being considered aside from price. So I can't emphasize enough that it is a specialized skill. I think I've already talked about from a mechanical consultant perspective. There are a number of consultants out there that do specialize in geothermal, and there are a number of mechanical engineering firms that do specialize in geothermal. Some of the largest firms out there have in-house people, but there are mechanical engineering firms that are great that don't specialize in geothermal. So the one question I always recommend asking is if they have in-house people that specialize in geothermal field design or geothermal in general. And if they don't, just make sure that you encourage them to have somebody on side that really understands the technology well, especially on your first project while you're getting to learn it. And I can't see the bottom of this slide, Catherine. Sorry.
Specialized trade, cheaper isn't always better.
I've already said that. cheaper doesn't mean, okay, yes. So cheaper doesn't necessarily mean better, guys. Like any industry out there, there are cowboys. And that's why when I'm talking about, we've talked a lot about quality and the importance of quality, and whether that's around design, drilling, or integration. This is a specialized skill. You are building infrastructure. At the end of the day, you're not just connecting to a pipe. You are actually building your infrastructure, and you want this infrastructure to land to last 100 years. At the end of the day, the pipe that is going in the ground with the loop is warranted, I believe, for 50 years, but should last you 100 years. So if everything is done properly, you should have a system that'll last you forever, where you might just have to change some filters or replace some heat pumps after 30 years. But if everything's done right, you're setting your building up for success forever. That's what I'm going to close on procurement. Are there, I see there's questions. I just want to see if those are from you or not.
There's one about shallow horizontal geofields being retrofitted to a more stable vertical field. That's definitely not a procurement question.
It can be done. It's yeah, you can retrofit anything at the end of the day if you're worried about stability. But if the horizontal field was done right, it should be stable. The one thing I say, when you're talking about shallow, horizontal versus vertical, when you put in a horizontal field, so long as you're putting it somewhere where you're never going to change anything, you're fine. But if there's going to be any type of redevelopment, you need to remember with the horizontal field, you're going to disrupt your HVAC system, and you're going to have to redo the field. So if there's any thought of redevelopment down the road, you definitely want to look at vertical versus horizontal.
Okay, I think that I don't see any specific procurement questions, so why don't we move to financing?
Okay, yes. And again, I'm not going to talk a lot about this. I just want to make sure the municipalities that I haven't spoken to are aware that this exists. And I will open by saying this is not commonplace in the municipal world. However, there is a lot of chatter right now, and I believe this is going to become more relevant based on budget shortfalls because of what happened with the pandemic. So the concept behind a geothermal utility is very simple. It's just like an N-wave for geothermal, if you understand what N-wave is. So there are a handful of companies out there that will come up, and they will pay the full capital on the geothermal system. So they will pay.
Oh, Paul, I seem to have lost you. I'm hoping it's just me and not everybody else.
I can't hear him either.
Paul, okay, okay. Then it's just me. Okay. Sorry to cut you off there. Keep going.
Yeah, I don't
Sorry, I
have.
can't hear Paul as well.
Yeah, I can't hear him, Catherine.
Okay. Okay, well, why don't we just go with what we have here on the screen? I think this pretty much covers what he was going to say. Utility takes on the capital costs. The building owner agrees to purchase the energy from the field. A 30-year time span would be common. So building gets the geothermal system without the significant capital cost, which, as we all know and discuss time and again, cost is one of the major barriers, if not the biggest barrier, to reaching net zero carbon buildings.
I'm back.
Yep. Oh, you're back.
Sorry about that. For whatever reason, my internet kicked out, so I just hotspotted. I apologize to everybody. Am I just continuing really fast?
Yep, sure.
Okay, so I was talking about the concept of the geothermal utility. They pay the capital on everything up to the manifold. This does not include internal heat pumps, meaning if it's a condo, for example, this would not include the in-suite pumps. Generally speaking, it's a 30-year deal, so you would agree to buy the energy from the geothermal loop field. Generally speaking, it's 30 years. And yeah, you're basically getting geothermal without having to put out capital. It's very commonplace in the private sector, and I would even go as far to say it's happening in 70 to 80% of buildings at least. And like I mentioned, there's a number of municipalities, but also there's provincial and federal discussions around this utility. The situation changed with this pandemic because we always hear about budget shortfalls. So everybody's trying to figure out how can we make things happen without having to put this excess capital out. And everybody knows geothermal is it's not cheap. And the reason it's not cheap is because, like I said earlier, you're building infrastructure. You're not just tying to a pipe. So this type of a model, I believe it could really help the municipalities. And that's why a number of them are looking at it. But also the industry understands that from a general perspective, the public sector does like to own their own assets. But in light of what's happened with the pandemic, I would urge you to, at the very least, take a look at this model, because it could make a lot of sense and save you a lot of time and money and hassle, because these organizations understand the technology very, very well. They want these systems to work perfectly because it's their investment. So a lot of the things that we've spoken about today, you no longer have to worry about any of that. They take it all on. So that's all I'm going to say about the utility model.
Fantastic. If anyone has any questions, please feel free to ask. Okay, moving on to our panel discussion, which we've had a lot of that back and forth, which has been great throughout. Now we have a few sort of specific topics for our panelists to talk about. So we've put together a few different questions to start off. So the first question, how do I know if my existing geothermal systems are operating as intended? What do I look for and what should I do? Maybe Dan, you could start us with this one.
Yeah. Oh, wow. That's the key question. I can be, for full disclosure, half of our systems, we don't know how they're performing. And the reasons are we don't have data. They were designed without, you know, they were not really designed in the past with a lot of data or points that were monitored by the BAS system, and those BAS systems were not centrally connected or remotely accessed. So we don't really know how well they're doing. I know they are performing. People are not complaining, so we can assume that they are doing well. But are they performing up an optimal level? I'm pretty sure no. The answer to that would be no. So things that I mentioned before, I think it's crucial to have the data, access to the data. So the building automation system has to be connected to it. Has all the points that are connected to it needs to be trended, logged, so you can remotely access them, so you can have the history. Things that you need to, I think, obviously from the ground, you need to monitor the temperatures going into the ground and out of the ground. You need to monitor the flow, unless it's really clear it's standard. It's not variable. So pretty much energy meter, I would always recommend having it on the ground. And as well, that will analyze the data, calculate the BTUs, kilowatt hours that are used, and can predict performance as well of ground source heat pump, ground heat exchanger, the bore field over next season or next couple of years as well. I would say during the design, we should set the intent so that the operators know what temperatures are supposed to be happening over each season and over next, typically for 20-year period, you need to know that. And so once we know that, like they are actually now even on third-party predictive logarithms, I guess web-based projects that systems are being developed that you can tap into that, pay for it. But I think the principle is the same. If we know what the temperatures are supposed to be as part of the design, the loop temperatures, then if something goes higher or lower than expected, then we need to have mitigating, we need to tell operators this is what you need to do. So well, Jeff mentioned a lot of heat sinks, snow melt, or fluid cooler as a last resort, putting it in the air, and or on same thing on the cooling side as well. If you need to get more heat into the loop, you know, if you have backup boiler, turn on the backup boiler for a couple of days to raise up the heat. So those are a couple of points that I think as operators because it's critical to keep that ground loop balanced. And I think as long as it's already it's designed and they know what they're supposed to do, and it's a design, all those measures are during the design are thought of. It's fairly simple for the operators to maintain the balanced loop. The problem always happens is that when they have no idea what the proper temperature is supposed to be, and even if they know, they have no idea what they can do about it. And then usually nothing happens until it becomes a problem, a big problem.
Actually, one thing I'll add here, and people may not know this, when it comes to balancing of a geothermal system, once a system overheats, let's just say it happens over a gradual period of time. Let's just say that period of time is 2, 3, 4, 5 years, and all of a sudden you notice a problem. It's going to take you the same amount of time to get that field rebalanced. You need to be aware that if you're not keeping an eye on things and things go long term, it's going to take you a long time to fix it. So that's why keeping an eye on and balancing the systems is so incredibly critical.
Well, Jeff, I would say, I mean, please kind of feel in to jump in, but I would say if it's set up, it's actually fairly simple for the operators to maintain the balance if they know, if it's designed into, if there is a design thought put into that in the first place.
I'll just jump in and say and reiterate, yeah, without monitoring and data, how do you know? Like, how do you know how the system is performing? How can you assess that? So, I mean, depending on sizes of these facilities, I mean, you can go from small fire halls to large commercial buildings, right? And so there's variations there, but in all cases, monitoring is important. But to answer the question, how do I know if it's working as intended? I mean, am I comfortable? Is there heating? Is there cooling? That's a big alarm, first of all. And there are ways to investigate without monitoring, but you don't get that long-term snapshot to understand performance over time, which is what you really want. You can investigate the heat pumps and understand how they're performing in that time. And they'll tell you, like, most of the times, the problems are either in the source side or in the distribution side. You know, we're talking about air flows, we're talking about water flows, and then we have a heat pump in the center of that. And the heat pump is just going to scream at you when there's a problem. It's going to flash lights and say, hey, this is what's going on. I can't move heat. I mean, all the heat pump is doing is moving heat from here to there. Well, I can't do that, and here's why. And then you can investigate and figure out what's going on. And it usually has something to do with airflow or water flow, right? But you don't get that long-term snapshot without the data. And so I would say, what are the critical success factors? It was already mentioned, is just as-built books. You know, when we're designing these systems and then constructing them, accurate as-built information is handed off to the operators, and the operators are trained because, yeah, the temperatures in geothermal systems are different than conventional, and operators may be coming from a building that's a fuel-fired building, and the temperatures that they're seeing on geo is like, oh, geez, something's going on here. It shouldn't be running that low of a temperature. And then that's when they kick on the boiler and think that's what they should be doing, but maybe not, right? So as-built books with accurate data, handoff, commissioning, and training of operator staff, very critical.
Yeah. Oh, yeah, add to that, the clearly defined sequence of operation. And as many simple, I mean, operating manuals are great if you want to do a deeper dive into what the issues, but they tend to be like, you know, a couple hundred pages long. So I think the operators really need to have the cheat sheets, something that, you know, up to 10 pages, maybe even, hopefully even less, that will clearly state to them what they need to look at. What are the warning signs? What are the alarms? And obviously the BES needs to be set up for that. That they will show dashboards that will show you, you know, color coded or however you want to do it, but I will show you the alarms. I'll show you, oh, this temperature is trending up, so pay attention to this, or the pressure is going up or down, whatever, as long as it's outside of the range that's expected, and that range can be obviously put in whatever the design is. They should be able to know about it, and then they should be able to, ideally, they will know what to do about it.
I just want to add one tiny more thing, is just kind of from my original conversation, is schedule. So when commissioning, we talked about buildings being dynamic and how they operate from day to day. Actually commissioning the schedules in the BAS so that the building operates as it was intended is critical as well. Because I know sometimes, maybe many times, building schedules aren't actually set up. So,
and one other thing I will add, and it comes up quite often around the operational side of things, especially in the municipal world. When there's a problem with the system, there's certain times where it's simply human error because someone just didn't understand the system. It could have been a change in staff or a number of different things. One thing the OGA is working on, and I think this is something that'll come out the latter part of this year or early next year, is an operational guideline for the municipalities of Ontario. And along with that, there could potentially be some direct training on geothermal. So that is something that is certainly in play. We're well aware that this is a concern for the municipalities, and it's something, as the Ontario Geothermal Association, we do want to address for you guys. And we are looking at a potential funding stream to make this happen. So we do promise to get the information to you through the Mayor's Megawatt Challenge and a few other channels once things get moving a little bit more on that. But I just wanted to make sure everybody knew that was in play.
That sounds fantastic, because yes, operations are a very key piece of this. So having something like that available, I think, would be immensely helpful for people.
Yep.
That's fantastic. Any other points anyone wants to make on anything that we're...
Well, on critical success factors, I will add as well, I think obviously Paul talked about procurement before. If it can be done, I personally like design build. That's my experience. Not particularly, not just geo-related projects, but renewable. That's where I've been my world for the last dozen years. And I can tell you, we got much better results every time we went with design build than versus. And I wouldn't. And for the retrofits, I wouldn't do geo as a only measure, as isolation. I would do deep retrofits. It's really no point in doing, when you're touching an existing building, when you're replacing stuff, there's no point in just adding geo to everything without holistically integrating into the building and renovating, well, as much of the building as you can. So multiple measures, controls, sequence of operation, everything that needs to be done for the retrofits. That's the best source. And I think design build type of projects will be work really well for that. I mean, those two pilots that we are having are done that way. So we'll see. I can tell you next year if it's a success or not. Looks like it's going to be a success. So I'm happy about that, but we'll see what happens next 6 months. And as well, at minimum, I would suggest that if there are evaluation that can be done during the procurement, it should be more like it is 60-40 towards the technical side and 40% price, or even less on the price side, so that you get you get the kind of combination between the qualified installer and the price, versus just getting the lowest cost, which sometimes tends to get us in trouble.
The one thing I want to add, and actually, Dayon, everything you've just said, I agree with you 10,000%. And we didn't talk a lot about retrofit today, but the one thing that everybody keeps in mind when you're looking at retrofit, there are a lot of other variables to factor in when you're looking at that. And I think the primary one is age of building, because And I know some municipalities have a big portfolio of buildings. So if you've got a building that's say 80 years old that doesn't have forced air and you're on electric resistance or you're on some type of steam or radiator system, geothermal potentially won't work with that. So aside from the cost to build the geothermal infrastructure, you have to factor in that there could be dramatic internal infrastructure costs. So I always say when it comes to retrofit, you have to look at that from a case by case. You can't just say, hey, we want to go with geo because we want to reduce carbon, because you have to, sometimes it may not work, or you may just have a lot of costs, a lot more costs than you're expecting. So I always say with retrofit, just be careful with that one and make sure you look at all the different variables.
Yeah, exactly. And on deep retrofits, that's I think we should start. Geo is one of the measures that will be looked at. When we did ask in our procurements that they look into geo and actually compare it to air source heat pumps, but it wasn't. It was a mandatory measure to look at during the RFP stage, but we left the open basically during design that you know, if it makes sense, then we'll do it. Of course, we cannot. We have to reduce the carbon. The most efficient way to reducing carbon of building A may be, and for between building A and building B could be completely different. And so how we design future deep retrofits will be more flexible as well.
There was one more question, by the way, Catherine, and it's a Jeff Hunter question. It's not a me question. What are considerations for the refrigerant choice for the heat pump for net zero buildings, such as selecting natural refrigerants, ammonia, GWP equals 0 versus synthetic refrigerants? Jeff, can you answer that one?
Well, it might even be a Zena component, because I'm not as familiar on the net zero side. I'll say from my side on that, with heat pumps and the manufacturers, they're being driven by phase outs, phase outs of refrigerants. And so as the manufacturers are forced to phase different refrigerants out, they're incorporating new refrigerants into the equipment. So from my side of the equipment, I kind of look at it from an availability standpoint and what the heat pump manufacturers are doing.
So my question back to you, Jeff, is what refrigerants are being used right now? What are the most common? If somebody was to install a system now, what are the refrigerants they're using? Because I understand where the question is coming from, because here we are trying to build net zero operational facility, but any leaks from refrigerants and even the use of the refrigerants and their end of life has a lot of global warming potential associated with it. So we do want to switch to ammonia and CO2 as much as possible. But how does that factor into what the systems are able to receive now?
Yeah, so there's, from my knowledge of it, a lot of legacy, larger, if we're talking conventional buildings, larger chiller plants are like R134A for the last, I don't know, a long time. And there are new refrigerants, not, a CO2 or ammonia in this situation, that would be a drop-in. So the existing buildings with existing equipment, there could be drop-in replacements for R134A. I think actually 513 is a drop-in for 134A. And then smaller unitary heat pumps currently are 410A, which I think there is already that came in the early 2000s, and I think there's a planned phase out for that sometime fairly soon. So, and I forget what they have for that, but there's a drop in for that. So they kind of step out. That's the only way I can answer that one.
Yeah, I think.
Yeah, R134A, I'm looking at my list, has a global warming potential of 1,430.
Oh, yeah.
It's quite big. So there's definitely importance of talking about refrigerants as part of the conversation when you're looking at the geothermal system and having your design team address that.
Yeah, so the ones that we are seeing the last year that Sean just mentioned, those are typical ones that now have the global warming potential around 600. So it is, like maybe a third of what the standard was a few years ago. But it's not ammonia, or it's not CO2 refrigerant has extremely low. So it's kind of a balance between, at the moment, I guess it will be balance for the current projects, what is available on the market. Like if it cannot get, or if it's a special order, it's not even possible to buy it on Canadian market here, then unfortunately we have to do what's best. But if we have the choice between is it 513 and 134A, then definitely go with the lower one.
Great. Anything else anyone wants to add here under critical success factors or common issues in the operations, maintenance, and monitoring? Any key takeaways? I see we've got 5 minutes left here, so maybe each of our panelists could just sum up with the main key takeaway here from their perspective.
I'll start. I think we kind of emphasized a few things at the beginning. You need to look at things differently, because if you're looking at net zero, you can't look at things the way you've always looked at them. You have to remember that you're building infrastructure, because the one most common thing I've heard, whether I'm talking to private or public sector, it's always, oh my God, geothermal is expensive. Well, of course it's expensive. You're building infrastructure. So you need to remember that there is a cost associated with doing that. When you move forward with it, we've talked about kind of the 3 key pillars. You've got to have a really good design, you've got to have a good driller, and you've got to have good integration. And if you miss any one of those 3 pieces, you have a huge problem on your hands. So focus on quality from a procurement standpoint. Cheaper isn't better, and just make sure that you're looking at everything through the whole process to make sure you're getting top quality work, because you want this system to last 100 years. You want it to outlast your building. That would be my 2 cents.
Sounds good. Perfect.
I can add commissioning starts from day one in the design, not at the end of the project. Monitoring a verification plan is crucial. Operator training, because we have, unfortunately, high turnover of operators. So operator training, refresher trainings, and as well, if project, just building up the capacity of operations staff in each municipality. That's something that will be great to do.
Yeah, fantastic. Jeff, any final thoughts?
Yeah, so I mean, we use the word expensive, and I don't like using that word, because I mean, there's a lot of complicated or seemingly complicated systems in designing these systems to put them together to work properly and monitoring that. But at the end of the day, you're buying your energy up front, essentially. So that's what's causing the expense. Normally we'd be paying that over the course of the 100 years, but instead now you're kind of buying that up front. And the costs are the infrastructure in place to move that energy to and fro from source to sink. So those are the costs. The energy itself essentially is free. The thermal energy that you're extracting and rejecting to the earth, that's free. And so all I want to say is thermal energy that you can access at point of use, on demand, 24 hours a day, 7 days a week, that essentially is free. That's never going to go out of style. So there's a shift in momentum here, and I think those are the messages that need to catch on. And thanks for having me participate.
I'd like to add on to what Jeff just said. It's the capital cost, upfront capital cost, that hinders a lot of projects from entering into it. But when you start doing the payback analysis, because it's free, you realize that it's not so bad. When you are operating a building that's going to be around for 50 plus years, having payback periods, anything under 30 years is fantastic. So, still there's the issue of capital costs. So there are available incentives out there that you should keep track of. They're constantly changing, and you can apply for them, like the Green Municipal Fund, for example, or there's things that come out through TAF when it comes to feasibility studies and compensating for high performance building initiatives. So just do a little bit of research, get your design team doing some of that research too, find out what incentives you can apply for. I know assisted with some incentives for the City of Toronto working with Dayon on a project, and they were able to offset the cost of the feasibility study itself, potentially more. So just, you know, don't let that be what stops it.
Hey, one other thing to remember, geothermal doesn't blow up, unlike its competition that potentially can, so it's a lot safer as well.
Okay, one last comment. A lot of people talk about the upfront capital cost. It's because they're thinking about the delta, comparing it to natural gas. We need to be at a point where we don't talk, if we're talking about carbon and we're taking climate change seriously, if your municipality declared a climate emergency, nobody should be talking about high carbon energy sources anymore, which include natural gas. That needs to be
Absolutely.
taken out of the equation. And suddenly that delta is not as significant, because if you're comparing it to a conventional building and a conventional system, then you're not starting out at the baseline that you're trying to achieve, which is reducing carbon. So it's not a true comparison.
Right. Okay, it is now 2:30. Here's the closing remarks, which I won't reiterate because they're up here on the screen, but we will be sending out the webinar recording, the question and answer document. I would like to say a huge thanks to all of our panelists, Zaina, Dan, Jeff, and Paul, for this fantastic webinar. I think this is going to be really useful for the municipalities. And again, a big thanks to Perkins and Will for sponsoring today's webinar. Thanks so much, everybody.
Our
Thanks,
pleasure.
everybody.
Thanks. Take care. Bye now.